Hello, everybody, wonderful Earth Science kids. This is another episode of Yo at Home. So, we're going to be talking about climate factors today, just kind of putting the last touch on the weather unit. And we want to take a look at the things that make a big impact on the climate of an area. The first, of course, is going to be your latitude. If you're at 0 degrees latitude at the equator, what's life going to be like there versus, say, up at 60 degrees north or 60 degrees south on the globe? What's life going to be like there? All very much dictated by latitude, and it's going to make an enormous difference, the biggest difference of all. But elevation is going to make a fair difference too. If you're at the equator, you'd expect it to be nice and warm, but if you're at the top of a, say, 14,000-foot mountain at the equator, well, it's going not to be very warm. So elevation is going to make a big difference anywhere you are. Mountain ranges standing in the way of air moving is going to make another big difference, not just being at the top of a mountain, but on being on which side of the mountain you're on. That will change things radically, as we'll see. Nearness to large bodies of water will also make a big difference. Water takes a long time to heat up and a long time to cool down, so anybody near that body of water is going to have their climate moderated a great deal. Ocean currents. We have both cold and warm ocean currents, and we have sometimes air blowing from them onto land or not. And that will make a difference into how an area's climate works out. Then we have planetary wind belts, not just which way the air is going, but what's happening to air in certain belts. Sometimes air is rising over you. That's going to make stormy conditions. Sometimes air is sinking over you. That's going to make very, very dry conditions. So that we'll take a look at. And then we'll finish off with typical storm tracks, which way do hurricanes usually wander as we move about the globe. So let's take a look at the first one, which is latitude. Latitude. So we think of the equator running through here as very hot, and in fact it is. You might tend to think that the sun is always overhead at the equator, but that would be wrong. The sun is overhead at the equator September and March, right around the 21st of the month of each. So twice a year the sun is directly overhead at the equator. But if you look at this, after the sun is overhead at the equator in March, it continues its northward movement until on June 21st, it is directly overhead at this, which is the Tropic of Cancer. And the Tropic of Cancer would be the farthest north the sun's rays can be directly overhead. After June 21st, the sun's direct overhead rays begins moving southward till it gets back to the equator in September 21st, and it continues moving southward until December 21st. And then it would be right overhead here, 23.5 degrees south, and this is the Tropic of Capricorn. All right, so after December 21st, it starts moving back and forth. So everywhere in this region here, we could describe it as the tropics. It is hot in the tropics. It is hot. You do not need to own a jacket if you live in the tropics, unless, of course, you're up on one of those mountains. But it is invariably warm or hot down in the tropics. If you go above the area where the sun could have its rays directly overhead, now you start to tilt pretty far away from the sun in the wintertime. You start to tilt pretty much towards the sun in the summertime. So we would describe this as variable. We can have the temperature, well, look in your closet. That's the biggest way to see how this goes. You have summertime clothing where you could get away with shorts and t-shirt and sandals and be as happy as can be. You also, I suspect, in your closet have some thermal long underwear, big heavy sweaters, jackets, and hats, because it gets very, very cold. This is the temperate region, where the temperature varies tremendously, and we have that from 23.5 degrees north all the way up to 66.5 degrees north, and in the southern hemisphere, the same latitude variable climate happens. So these are the temperate climates, and it changes how we have to deal with things. If you look at all the creatures around, creatures have to deal with very hot conditions to very, very, very cold conditions. And some hibernate, some migrate, things like that. Down in the tropics, creatures don't have to deal with that. They can be the way they are all year long. People too. Now, in the above 66.5 degrees north and south, it is just cold. It is cold. Sometimes it's incredibly cold. Sometimes it's just merely really cold. But it's cold. North and south of the planet has very cold climate. This is the Arctic Circle, where for variable number of months, depending on where you are above the Arctic Circle, you could be in darkness in the wintertime for months. Similarly, in the summertime, you can be in light for months. But because the light is always very, very low angle, it never heats it up all that much. And the exact opposite seasons, but the same idea, is happening on the other side of the planet. So when it's completely dark here, it's completely light here, and vice versa. So latitude makes a huge difference in our climate. That would be one of the main drivers of climate. One other aspect of latitude that is incredibly important is the belts where you have air. And if we look at the limb of the Earth here, we can see this is where air is rising. Rising air makes clouds, and that makes storms. So this is always going to be moist here, and the air is not moving much. The name we give this is doldrums. The doldrums are the place where we have very little movement of air. Mostly the air is simply rising. As a sailor, this is not a good place to get caught in if you're depending on wind power to move. And a lot of storms here. This is rainforest area, warm and moist. By the time you get to 30 degrees north and 30 degrees south, all the air is sinking on top of you. Now, it also makes for very few winds and very bad times for sailing ships. These are known as the horse latitudes. And what we have here, well, when the air is sinking, the air is compressed, it heats up, it evaporates all the water vapor in it, and you get very, very dry conditions. So high pressure, air is sinking, and dry. At the equator, with the rising air, it's low pressure, moist. So where the pressure is high, you'd expect the opposite. And in fact, this is where you get the biggest deserts on planet Earth, in the 30 degrees north and 30 degrees south. Air is just sinking all the time. It's very hard to have any clouds at all. Very hard to have any precipitation without those clouds. So you have, in the horse latitudes, you have nothing but desert and dryness. By the time you get up to 60 degrees north and south, we're rising air again. And there we have the moist climates, and these are known as the roaring 60s. The roaring 60s because the storms you get here are truly awesome, and it is so cold and miserable. This is not a happy place to be. Low pressure, rising air, storms. Interestingly enough, 90 degrees north and 90 degrees south, we have sinking air, and we have, again, desert conditions. Now, you might not think of Antarctica as being a desert, but in fact, Antarctica is absolutely a desert. It gets very little precipitation there. The reason it's snow-covered, well, it's so cold, what little precipitation it gets doesn't melt. So we have a desert of ice, and a lot of clear blue sky days. Certainly some storms come through, but we have sinking air making high pressure. So this is the other aspect of latitude, and that's going to make a big difference in terms of any place's climate. The next big player here is going to be elevation. What is elevation going to do? Well, elevation, what heats the air is the warm surface. Sunlight hitting the warm surface. So sunlight coming down hits the warm surface, turns into heat, and that heat then heats the areas down here. But when you climb up a mountain, you are far from the warm surface. So if you have somebody up here, they are going to be cold versus somebody down here. You are simply getting far away from Earth's surface, from the bulk of the Earth's surface, where all the heat is being made from sunlight. And while you do get sunlight up here, there's no other mountains right up here. So you're not making much heat in this area. So it is cold. Elevation leaves it very, very cold. Okay? After that, then we have to talk about mountains with moving air. And as we have air moving into mountains, well, if we have a warm wind, moist, warm wind, and it rises up over a mountain, it's going to cool adiabatically. It's going to reach its dew point. It may form, after its dew point, large clouds, and those clouds may certainly precipitate a great deal here, forming a cool rainforest. Thing to pay attention to is that there is a great deal of heat released from condensation from this cloud. If that cloud has rained out a lot of the heat, a lot of the water that it's condensed, the heat is left here. The heat remains, and now that the air is sinking, it warms adiabatically. It's being compressed, and it warms. So down here, on the other side of the mountain, you'd have a dry desert. So you'd have a cool rainforest on one side of the mountain and a dry desert on the other. Obviously, the bigger the mountain, the more this has an effect. But that's the big effect of mountain ranges on a climate of an area. Now to talk about water, we have to talk about something called specific heat. Specific heat is the amount of heat needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. Okay, look at the number for specific heat of water. Might not seem very much till you compare it to the other numbers. Water, it takes 4.18 joules per gram per degree Celsius to heat up water. So if I have 1 gram of water and I want to heat it 1 degree Celsius, I need 4.8 joules of energy in order to accomplish that. Okay, look at granite or basalt. Typical rocks that the land is made of, it's much less. It's more than 4 times, about 5 times as less heat is needed to change the temperature of these things. So water has a very high specific heat. Granite, basalt, rock in general has a very low specific heat. So the point, it takes a great deal of heat to change the temperature of water and much less heat to change the temperature of land. On top of that, there's a few other things going on. When you have sunlight penetrating water, well, it penetrates, it goes deep into water. So it's trying to raise this whole mass of water and to change its temperature. So the light heats up the water deeply. The light goes deep. On top of that, some of the water is evaporating, stealing heat that way. Meanwhile, on land, the light hits the surface and only heats up that surface. Okay? Eventually, it warms up the rest of the land, but really, that light pretty much is just heating up the first inch or so of the land. So land heats up very quickly, cools down very quickly. Not a lot of evaporation happening there to steal the heat also. Water heats up very slowly, cools down very slowly. So specific heat is what we need to understand so we can see that water will change its temperature very, very slowly. Land will change its temperature very quickly. So let's take a look at this. We have oceans next to land. So we have sunlight on the ocean. It's going to moderate the temperature. It's hard to change the temperature of an ocean. Land, it's easy to change the temperature. So look at what I've done here. On a city, or if you have your beach house, there you go, a beach house, it's going to have a small temperature range. Cool summers, the temperature's not going to go up very much in summers. Temperature's not going to go down very much in winter. So cool summers, warm winters, relatively small temperature change. Far from the ocean now, you're going to have a large temperature range. You're going to have very hot summers and very cold winters because you have no water to moderate it. One other big effect is if winds generally blow from the water, it's going to have a big effect from the water. So if you have winds blowing from the water here, that water is going to greatly affect how the land's climate is. right? So there's going to be a big moderation of it. But if the winds generally blow from the land towards the water, it's going to have a small effect. Someplace right near it will be affected, but someplace a little further inland will have very little effect. So oceans moderate the temperature tremendously, and winds determine how much that moderation covers onto the land. So now we've just drawn a little hypothetical continent here, and consider this is the planetary wind belts here at 0 degrees and 30 degrees north and south. Right? So in the tropics, we have air. This is remember the ITCZ intertropical convergence zone, where all this wind is coming in. So if we look on the west coast of almost all the land on planet Earth, we have cold ocean currents coming down from the northern areas. On the east coast of almost all land, you have warm water ocean currents coming up from the equatorial regions. So look at this land. We have wind blowing this way from 0 to 30 degrees. So that means this entire region here is going to be warmed by that wind. Okay, this entire region would be warmed by that wind, right? And over here, I have air currents coming in from the land here, and I've clearly done something silly here. Let me fix that. Because these are going to continue this way. They're not going that. They're going this way. So over here, this air is going to, even though this might be pretty warm here, this is on a cold ocean current, and it's going to be cooler right in here. Coming in this way, it's going to be cooler right in here. And this will not be moderated very much at all by the ocean current. So you need to have air blowing from a particular current onto land in order to bring the effects of that current here. So you have warmer on this side, but even though this is cool, it would be cooler right near the shore, but not very much inland because the air is blowing this way. Similarly, the air reverse course up here, the air is then going to be cooling this land. This would be the case of California. California has a latitude that should make it very, very hot. It's not very hot because you have a cool ocean current, and you have winds blowing from that ocean current onto land, cooling it off significantly. So the ocean currents will affect it, especially when there's wind blowing from them. The last thing to talk about is the typical storm tracks. Now, this is the U.S. East Coast. This is the west coast of Africa. We have thunderstorms that start up on the west coast of Africa that move out onto the ocean. They're blown by the winds here, which are blowing in this direction, and these are carried out over the Atlantic Ocean, where they tend to develop into significant hurricanes. As they come up, they can take a few different tracks. One of the ones we see, we very often are threatened by it, and then it turns completely out to sea. And that is typical. As it comes up, it is turned outwards here. Sometimes it does not turn out in time, and it hits us directly, and very often will then ride up as it turns out that way. Occasionally, they will come all the way into the Gulf of Mexico. Sometimes the hurricanes themselves will start up right in the very warm waters around here. They'll move into the Gulf of Mexico, and again, they will turn up, and they will hit the various U.S. states as they come up through here. So typical storm tracks, they'll move out this way. Hurricanes get very unpredictable as to exactly what track they're going to take, but in general, you can anticipate there's going to be a turn as they come up north of the equator here. So that will turn the hurricanes that way. And that is the basic climate considerations, the climate factors that affect our world.